Good evening, I am Mr. Ish. Thank you for joining me. We're looking in this video at even functions. This topic comes up in the functions part of pre-calculus, but the actual implications and the applications become apparent in calculus. However, in high school you will be introduced to even functions. What exactly is an even function? How about this? At the very basic level, even function is anything for which most likely you'll have something like this. If you had a curve, you'd have a representation like this in terms of a coordinate pair. You could have two different x-axis values give rise to the same y value. How can we put that in terms of numerical form? How about this? Minus 2 comma 4 and 2 comma 4. Look at it. You have a plus 2 and you have a minus 2, but they're all giving you the same y value. Even functions in terms of graphs are those which are symmetric. They're symmetric about the y-axis. They have y-axis symmetry, and that's exactly perhaps the best way you want to remember them. Anything for which you can do a right and left mirror symmetry across the y-axis, between right and left you have a little symmetry about this y-axis. That right there is a graph which will be even function. Example could be a parabola, right? You have y-axis symmetry. Another type of graph could very well be the cosine function, which looks something like that. It's symmetric about the y-axis. You can have a bunch of other functions such as this. The absolute value is a even function. How about this? The secant function. If this right here is one of the vertical asymptotes, the secant function would look something like this, and that would be symmetric. In all these instances, you have, let's just look over here, you'd have a specific x-axis value, minus x. Here you'd have an x, positive x. They would both give rise to the same y value, and hence you're seeing this minus x comma y in terms of the even function. But there's a good rule you can follow with regards to even function, a test of even functions. That good test of even function can very well be represented in this form. If you have a certain function which has a x value, if you were to put the minus x value, it would make no difference. Each of these would give rise to the same end result. Think of this. Here's your f of x is equal to x to the 4 minus x squared. Is this an even function or not? Well, you have this and you compare it with this, f of minus x. In this instance, you put minus x in places of x. You'll have minus x to the power of 4 minus x to the power of 2, and you see if there's any difference. If there is no difference, then your function is an even function. Here you end up with x to the 4, here you end up with x squared. You compare them and you realize that this right here is an even function. How about, let's look at just another example, then we can look at our questions. If you have a function which is this, you have 2x squared minus 3x. Is this an even function? Well, you have to find out. You put minus x and you plug it in places of x and see what happens. You have that and then you have that. When you do it over here, you still end up with 2x squared, but when you do it here, you get a 3x. And here you see the difference. So f of x equals 2x squared minus 3x is not an even function. It isn't an even function. It will be something else. It could either be an odd function, highly unlikely, but it could be a neither. Something which is neither odd, neither even. But remember, this right here is what you're learning as to what is an even function with regards to recognizing it. You want to recognize or be able to recognize an even function. It will be symmetric about the y-axis and you'll have something like this. And remember, anything which is looking like this, it will fail the horizontal line test. Even function normally fails the horizontal line test because you don't have a one-to-one representation between x and y. You don't have that. You have types of curves which have horizontal lines going at more than one point, and therefore even functions, right? Their functions generally do not have inverses. They won't have this inverse unless you did some sort of exception or some sort of change, and then you can very well develop that one-to-one relationship for a function and its inverse. But this right here is a little bit of extra information, but do keep in the back of your mind that even functions have this type of format. They'll normally fail the horizontal line test, and therefore generally, unless you did some sort of change to their domain, they won't pass the horizontal line test and they won't have a inverse. Okay, let's look at our questions. Question number 1. Here's your equation right here, and decide if this is an even function or not. Well, if you wanted to graph it, that's perhaps the best way. You're looking at something which looks like x plus h. It is shifted 2 units to the left, and you have something which looks like that in terms of its representation. Vertex at minus 2 comma 0. Is this even function? No, it isn't. Look at it. With regards to the y-axis, it's not even symmetric. You have this portion right over here, and you have this much portion here, and of course the rest, but there's no symmetry here on the y-axis. It definitely is not. But your other ways, you could do it like this, and you would have minus x plus 2, And this right here, minus x plus 2, is certainly not the same as this. It isn't. So these are not even functions. You could say it's not an even function. Remember, perhaps the best, easiest way to remember if an even function is or it isn't is by means of graphing it or by means of doing this test. So our question number 1 is done. This by no means was an even function. How about this? F of x is equal to 2x squared minus plus 1. Minus 2x squared plus 1. Is this an even function or not? Generally, parabolic functions are even functions, and you would find that to be the case. If you put f of minus x, you'll have minus 2 times minus x whole square plus 1. When you do the simplification, you still end up with minus 2x squared plus 1. So it does check out. If you were to graph it out, you know it's a parabola shifted up by k units, right? But it's pointing downwards, and this right here, you have a minus a steep a value, so it's going to go down sharp, vertically stretched. But again, it's equally represented on the left and the right of this y-axis. Therefore, it is an even function, and it's symmetric about the y-axis. Remember, even functions, the test again, f of x is equal to f of minus x. They're symmetric about the y-axis, alright? They have y-axis symmetry, and that's perhaps a good way of remembering it. Both of these should be what you are looking for, and if you graph them, they look equally mirror image on the right and mirror image on the left of that y-axis. And I think we should end the video with that. Thank you for watching. Have a nice day.